This is my 7th video lesson for Unit 14. In this lesson, we'll be describing electrolytic cell and its applications. Go to page 28 in the class packet. Take a moment to watch a TED video on why Voltaic cell eventually stop working and how does rechargeable battery work. The link to the video will be in the descriptions. Once you watch the video, resume this one. Learning target. At the end of the lesson, I'll be able to describe parts and applications of electrolytic cell and compare it with a Voltaic cell. Homework is number 7, which is a Junopod based on this lesson. There will be a quiz Junopod on PowerPoint 5, 6, and 7. So why do Voltaic cells stop working or die eventually? From the video, anode is used up, there's no more atoms to be oxidized, there's accumulation of waste products, and the redox reaction has reached equilibrium. How do rechargeable batteries work? They do the reverse reaction. Is the reverse reaction spontaneous? No, because it needs a power source. What type of electrochemical cell is this? This is electrolytic cell. Electrolytic cell uses electrical energy to produce chemical energy. It can be 1/2 cell instead of 2, and it needs a battery or Voltaic cell to work. Is the reaction electrolytic cell endodermic or exodermic, and why? It is considered endodermic because it absorbs energy from the battery or Voltaic cell to work, so it's non-spontaneous. In contrast, if a Voltaic cell is spontaneous, it is exodermic because electricity is produced. Here's a diagram of electrolytic cell. Here's the anode and the cathode in a half cell filled with electrolyte. Electrolytic cell needs a battery to operate. The anode is labeled positive and the cathode is labeled negative. The reason for this is to illustrate the non-spontaneous nature of electrolytic cell. Just like the Voltaic cell, electrons travel from anode to cathode. As you can see, electrons are negative and the cathode is labeled negative as well. Same charge will repel each other, so this is non-spontaneous, and a Voltaic cell or battery is needed to force this to happen. The anion in electrolyte will be attracted to the anode, and the cations in electrolyte will be attracted to the cathode, due to opposites attract. This is from PowerPoint 5. Just as a review, both Voltaic cell and electrolytic cell are considered electrochemical cells. The Voltaic cell was covered in PowerPoints 5 and 6. This PowerPoint will focus on the electrolytic cell and its applications. Let's first compare Voltaic cell and electrolytic cell. The Voltaic cells on the left and electrolytic cells on the right. Let's first label the anode and cathode in each cell. In both cases, electrons travel from the anode to the cathode. Next, we're going to label each electrode as positive or negative. In a Voltaic cell, the cathode is positive and the anode is negative. In an electrolytic cell, the anode is labeled positive and the cathode is labeled negative. The reason for this is to illustrate whether the cell is spontaneous or not. A Voltaic cell is spontaneous. Since electrons are negative, they're going to travel to the cathode, which is labeled positive. Opposites attract. In an electrolytic cell, it is not spontaneous because the electrons are not attractive to the negative cathode. Same charge will repel each other. Therefore, a power source is needed to force the electrons to go from anode to cathode. Now let's write the half reactions for each cell. Let's start with the Voltaic cell. Oxidation always occurs at the anode. B is losing an electron, becoming B+. Reduction always occurs at the cathode. A+ is being reduced to A. Now let's look at the electrolytic cell. Same as the Voltaic cell, oxidation always occurs at the anode. A is being oxidized to A+, and B+ is being reduced to B. As you can see from the redox reaction and the half reaction, the electrolytic cell does the reverse reaction of the Voltaic cell. Now let's compare and contrast Voltaic cell and electrolytic cell using a Venn diagram. A Voltaic cell is considered a battery. The redox reaction is spontaneous. It converts chemical energy to electrical energy. It's exodermic. It needs a salt bridge and it needs 2 half cells to operate. And the anode is labeled negative and the cathode is labeled positive. For electrolytic cell, It needs a battery. The redox reaction is non-spontaneous. It converts electrical energy to chemical energy. It's endothermic. The anodes labeled positive and the cathodes labeled negative. Here are two possible applications of electrolytic cell, electroplating and electrolysis. We'll cover these two applications later on in the lesson. Here's what Voltaic cell and electrolytic cell have in common. They both conduct redox reactions. Electrolyte is needed. Electrons move from anode to cathode. Oxidation is conducted at the anode. Reduction is conducted at the cathode. Cations move towards the cathode, and anions move towards the anode. Learning check number 1. A Voltaic cell differs from electrolytic cell in that a Voltaic cell does what? Pause the video, resume as completed. Since the Voltaic cell is exothermic, energy is produced when the reaction occurs. Answer is choice 1. Learning check number 2. Reduction occurs at the cathode in what? Pause the video, resume as completed. The answer is choice 3, both electrolytic and Voltaic cell. Learning check number 3. Where does oxidation occur in an electrochemical cell? Pause the video, resume as completed. Oxidation occurs at the anode in both electrolytic and Voltaic cell. The answer is choice 3. In the second part of the lesson, we'll focus on the applications of electrolytic cell. The first application is electroplating, and the second application is electrolysis. Electroplating is using electrical current to coalesce a reactive metal onto metal objects. Here are some examples of objects that were electroplated. Here's an object plated with gold. Here's an object plated with silver. Here's an object plated with copper. Let's look at a diagram of electroplating cell in your packet. This is an electrolytic cell. We're trying to plate the spoon with silver. Let's first label the parts of the electroplating cell. The piece of silver represents the anode. The spoon represents the cathode. The electrolyte is the silver nitrate. The anode electrode and electrolyte have the same metal, which is silver. The Voltaic cell is the battery. Oxidation occurs at the anode. Reduction occurs at the cathode. Electrons flow from the anode to the cathode. The piece of silver is being oxidized. Solid silver is being oxidized to silver ions, which dissolve in solution. Silver ions in solution are reduced at the cathode, becoming solid silver, which plates onto the spoon. Since this is an electrolytic cell, the anodes label positive and the cathodes label negative. Solid silver is oxidized at the anode, and silver ion is reduced at the cathode. Here's a GIF illustrating electroplating. The silver is being plated onto the piece of iron. Here's a GIF of electroplating copper onto a coin. We're first going to make a copper sulfate solution. This serves as an electrolyte. A battery is needed for this electrolytic cell. The anode is a copper wire. And the cathode is a coin. This is the setup. The copper is being electroplated onto the coin. Learning check number 4. The diagram below shows a key being plated with copper in an electrolytic cell. Given the reduction reaction for the cell, this reduction reaction occurs at what? Pause the video, resume as completed. Reduction occurs at the cathode, which is the key, which is A. The answer is choice 2. Learning check number 5. Which equation represents the half reaction that takes place at the fork? Pause the video, resume as completed. The fork is the cathode, so reduction takes place. So the answer is choice 3, electrons are gained. Learning check number 6. Which part of the electroplating system is provided by the fork? Pause the video, resume as completed. The fork is the cathode, and since this is an electrolytic cell, it is labeled negative. So the answer is choice 2. Electrolysis is a decomposition chemical reaction that is done using an electrical source. It forms pure elements as products. There's three types of electrolysis that you must know for the Regents exam. We'll go over each one. The first one is electrolysis of water. Water is decomposing into oxygen and hydrogen gas during electrolysis. Here are the reactions at the electrodes. Here is oxidation, and here is reduction. We're going to combine them to get the overall reaction. This redox reaction involves a transfer of 4 electrons. And here's the overall reaction. During the reaction, water is decomposed to oxygen and hydrogen gas. Which element is oxidized and reduced? By looking at these reactions, oxygen is oxidized and hydrogen is reduced. In summary, water is split into its elements in the electrolysis of water. Here's a setup of electrolysis of water experiment. These are pencils. They are sharpened on both ends, so the graphite is exposed. The graphite can conduct electricity. The aggregator clips is attached to the graphite and to the battery. Once everything is hooked up, the electrolysis reaction will begin. Gases will begin to form at the tip of each pencil. I am now going to play the video. Pay attention to what type of gas is formed at each pencil. The second scenario of electrolysis is electrolysis of aqueous salt. Brine means saturated solution of salt. Let's look at this diagram. Which ions are attracted to the anode and why? The anodes labeled positive, therefore the chloride and hydroxide ions will be attracted to it because opposites attract. Which ions are attracted to the cathode and why? The cathodes labeled negative, therefore the sodium and hydrogen ions will be attracted to it because opposites attract. Which gases are formed? Label it above. It is hydrogen and chlorine based on the equation which is being oxidized or reduced. Chlorine is being oxidized and hydrogen is being reduced. Write the overall reaction. In the electrolysis of NaCl aqueous, it produces sodium hydroxide and hydrogen and chlorine gas. Here's a GIF to illustrate the electrolysis of brine. The last scenario is electrolysis of molten salt. Molten salts are salts in the liquid state that can conduct electricity because of mobile ions. We're first going to label the electrodes. Anode is positive and cathode is negative in an electrolytic cell. Which ion is attracted to the anode? It'll be the anion because opposites attract. That's chloride. Which ion is attracted to the cathode and why? It'll be the sodium ion because opposites attract. Based on the equation, which is being oxidized or reduced, chloride is being oxidized and sodium is being reduced. Write the overall reaction. In this electrolysis reaction, NaCl is decomposing to sodium and chlorine gas. Here's a GIF of electrolysis of molten NaCl. Learning check number 7. The reaction is forced to occur by use of externally applied electrical current. This procedure is called what? Pause the video, resume as completed. The answer is choice 3, electrolysis. This concludes the video lesson. Remember to do the Juniper homework and quiz.